So this is a picture of the attachments of the diaphragm muscle, which is innervated by the phrenic nerve, which is levels C2, 3, C3, 4, and 5. And what we can see here is that there's left and right crux, the 3 and 4 here, that come off the lumbar vertebrae. And then we can see the attachment to the ribs as it circles around and really forms a separator between the thoracic cavity and the abdominal cavity, with some openings for various vessels and lymphatic structures. What we're interested in biomechanics is the function of the diaphragm. And we can see here is that the primary way we understand its influence on inspiration and expiration is how it changes the volume of the thoracic cavity. We can see here is the liver impression over here on the right, and the stomach, which is much softer, on the left. So we can see that if the abdominal contents move and the dome, this kind of central tendon, which is labeled 1 in this picture, descends and the abdomen flattens, we have a change in vertical dimension of the thoracic cavity of around 6 to 7 centimeters. Now during quiet breathing, it may only descend a couple centimeters. Right? And so that's one option. That's one way that the diaphragm may change the volume of the thoracic cavity or increase it so that we can inspire air. Now, the other way is it can change it in more than just the vertical dimension. And so if our abdominal muscles contract, which then pushes up against, causes pressure in the abdominal cavity, which pushes up against the central tendon initially will descend a little bit, but then become fixated at some point on the abdominal contents. And if that occurs, then what happens is now the angle of pull of the diaphragm muscle fibers is upward. So we would get some change in vertical dimension from the descending component of the dome, and then we would get an outward and upward change in dimension from movement of the ribs and their bucket handle motion, because the diaphragm is now pushing up, and that would naturally, because of the joint movements, move the ribs upward and outward. And by doing that fixation, so if the central tendon becomes fixated, we get a change in vertical dimension, a change in anterior posterior dimension, and a change in medial lateral dimension.